Hello, my dear students. Very good evening to all of you. So, in this video, we are going to see polynomials. I have discussed all the important topics under polynomials by giving detailed examples, and hopefully, this video will be very useful for you guys. And I have also given my contact number in the description. So, if you have any doubts for uh, any of the topics, you can feel free to book a class with me and then get clarified all your doubts. So let's keep rocking. Hello, my dear students. A warm good evening to all of you. So here we are going to see polynomials. Uh, all the important concepts of polynomials are given here. So we can go one by one. So first is introduction, and then comes geometrical meaning of zeros of the polynomial, and then comes relationship between zeros and coefficients, and then useful problem solving techniques. PSTs means problem solving techniques. Okay, introduction, I would have just given you a basic outline about polynomial. So that is, an expression is said to be a polynomial if the powers of the variable are not negative. So here it is negative. 1 by y can be written as y power minus 1. So hence it is not considered as a polynomial. But here all the terms are all the powers are whole numbers, so it is considered to be a polynomial. So it is the powers of the variable are not negative and also not fractional, so power of the variable should only be a whole number. So like that, I have given some examples about it. And then comes the degree of the polynomial, the highest power of the variable in a polynomial expression. So the highest power of the variable in a polynomial expression, suppose if they ask you this question and then they ask you the degree, you should write degree is not defined, because here first of all this is not a polynomial at all. So only for polynomial expressions you have degree, which is nothing but the highest power of the variable. So here the highest power of the variable is 3, so degree is 3. So if degree is 3, then it is classified as cubic. If the degree is 2, then it is classified as quadratic, and if the degree is 1, then it is classified as linear. Okay, next is the value of the polynomial. Very simple one. A polynomial is given, so if you have to find p of 1, just substitute x is equal to 1, you get the answer. So this is nothing but the value of the polynomial. Zeros of the polynomial, second topic. So zeros of the polynomial is also very simple. So you will be given a polynomial and just equate that polynomial to 0. So you will be getting the value of the variable. So that is called the 0 of the polynomial. So 2x minus 3, if you equate it to 0, you get x is equal to 3 by 2. So x is equal to 3 by 2 is called the zeros of the polynomial. And also you can find the zeros of the polynomial through the graph. That is the number of points it touches the x-axis. Please remember this very carefully. The number of points it touches your x-axis gives you the number of zeros of the polynomial. So clearly I would have given this is the x-axis and this is the y-axis. So here there are no points touching your x-axis, so it is no zeros. Here there's at one point it touches your x-axis, so you have 1 0 for it. And next is it touches your x-axis at 2 points, so you have 2 zeros, and here it touches the x-axis at 6 different points, so you have 6 zeros. So please remember this. They will be asking you for your MCQ. A quadratic polynomial can have at most 2 zeros. At most means at most means maximum. So that is, it can have no zero at all. So like the one I would have given here, it can have 1 0 and it can have 2 zeros. So that's the meaning of at most 2 zeros, maximum of 2 zeros. So next topic is about relationship between zeros and the coefficients of a quadratic polynomial. First, for finding the relationship, you need to know how to find the zeros of a quadratic polynomial. So I would have written here the steps. So finding zeros of the quadratic polynomial, which is of the form ax square plus bx plus c. So here the coefficient of x should be split into two parts such that the sum is always equal to the coefficient of x, which is nothing but b here, and the product of two parts is always equal to the coefficient of x square multiplied by the constant term. So here I have given an example from the NCERT textbook, x square plus 7x plus 10. The coefficient of x is 7, which you have to split into two parts. Sum is 7 and product is 10. So here you can do it a 5 2. So always remember, here the coefficient of x square is 1, and if the coefficient of x square is 1, you can directly do like this. So after you have found out the two values, pi and 2, you can just directly write x plus pi into x plus 2 is equal to 0. So x is equal to minus pi or x is equal to minus 2. So like that you can directly write, provided the coefficient of x square is 1. Here the coefficient of x square is 1. But in another example I have given, the coefficient of x square is not 1. So you have to do like a normal way. So here coefficient of x is minus 7, split into two parts such that the sum is minus 7 and product is minus 18. So here minus 9 and plus 2 fits. So you just have to write it here 6x square minus 7x. Instead of that you can write minus 9x plus 2x minus 3. So here carefully see in the first two parts here 3 is common and also x is common. So 3x is common. So remaining term will be 2x minus 3. And in the next two parts, nothing is common. So if nothing is common, you can take 1 because 1 is a common factor of everything. So plus 1 into 2x minus 3 equal to 0. So here in both these terms, 2x minus 3 is there. So you can take it as common and the remaining terms you can write it as it is plus 3x plus 1 equal to 0. So 2x minus 3 to 3x plus 1 equal to 0, which means the product of two terms is 0. One of them should be 0. So using this, you can find x is equal to 3 by 2 or x is equal to minus 1 by 3. So this is how you have to find the zeros of the quadratic polynomial, and after finding out the zeros of the quadratic polynomial, you have to verify the relationship between zeros and coefficients, which I have given in the next topic. So here I have actually made you understand how this relationship between zeros and coefficients is actually being derived. That is, you have to know this main formula: alpha plus beta equal to minus b by a and alpha beta equal to c by a. So you just have to remember this. Alpha and beta here in this example are 3 by 2 and minus 1 by 3. So you add it. 3 by 2 plus of minus 1 by 3 will give you 3 by 2 minus 1 by 3. You take LCM, you will be getting 7 by 6, which is equal to minus b by a. And alpha beta, if you multiply, 3 and 3 will get cancelled, you get minus 1 by 2, and this is nothing but c by a. Minus 3 by 6 is nothing but minus 1 by 2. So this is how you will have to verify. Okay. So, and I have also given some important problem solving techniques. So formation of quadratic polynomial. First of all, you have two cases here. In the first case, both the zeros alpha and beta will be given. So if both the zeros are given, you have to use this formula: x square minus alpha plus beta into x plus alpha beta, where alpha plus beta is sum and alpha beta is the product. When you are given the zeros, you can just add and multiply and then substitute it here. And then when the sum and product are given, directly they would have given you the sum and product. So in this case, you can use this formula: x square minus sx plus p. And you are for your useful identities, they'll be asking you numericals based on this directly, for which I have given you some very important identities. 1 by alpha plus 1 by beta, you take LCM, you get alpha plus beta by alpha beta, and alpha square plus beta square. This is an identity which is taken out from a plus b whole square. So you have to use this identity: alpha plus beta whole square minus 2 alpha beta. And here you have alpha beta as common, you take it out, you get alpha plus beta. So, and always you have to remember, this is one of the most frequently asked questions as well. Irrational roots always occur in pairs. I have given you an example. If 2 plus root 3 is a root of any polynomial, suppose if they give you a polynomial and if they say 2 plus root 3 is a root, they will be asking you to find out the other root. The other root has to be 2 minus root 3. So like this, you have got various varieties of questions in polynomials. All these things were explained. Hope this video was very useful for all of you. And in the next session, we'll be having a detailed discussion on some other topics. And thank you for your patience, and hopefully this video is very useful for you guys. So wish you guys all the very best, and let's keep rolling.